Good morning, students. Today we are going to discuss the last topic, possibly from the chapter Work, Energy and Power. So the topic which we are going to discuss, already we have defined this one in our previous class, that is your coefficient of restitution. Coefficient of restitution. Now what is this one? Let me try to brief it out. The degree of elasticity of a collision is determined by a quality called coefficient of restitution. Now elastic collision and inelastic collision already we have defined. Elastic collision, energy, kinetic energy and momentum both are conserved, but in inelastic collision only the momentum is conserved but not kinetic energy. So as per the definition, basically coefficient of restitution defines the elasticity of a collision. Now mathematically it is nothing but is your relative velocity of separation after collision divided by relative velocity of approach before collision. So if we consider any two objects, so before collision they are approaching, but after collision they recede. So relative velocity of separation after collision divided by relative velocity of approach before collision, that is your v2 minus v1 by u1 minus u2. In our previous discussion we have defined elastic collision, and under that case we have got that v2 minus v1 equal to u1 minus u2. Please check the topic which we had discussed in our previous class. Now the general definition for coefficient of restitution is your E equal to v2 minus v1 by u1 minus u2. Now for perfectly elastic collision, E equal to 1, it means v2 minus v1 equal to u1 minus u2, which one already we have discussed in our previous topic. Now for perfectly inelastic collision, E equal to 0, it means v2 minus v1 equal to 0. Now for inelastic collision, it is not perfect. For inelastic collision, the E comes out to be your 0 to 1. So within this value for inelastic collision. So in mathematics, you have to use this expression, or numericals basically. You have to use this expression for the coefficient of restitution. So based on the coefficient of restitution, I have specified one numerical. You please try it. It's a very simple. A ball moving with velocity 2 meters per second collides head-on with another stationary ball, that is at rest, whose mass is double the mass of the ball which is moving. If the coefficient of restitution is 0.5, find their velocities after collision. So please try this parameter in the expression E equal to v2 minus v1 by u1 minus u2, and the answer possibly is your v1 equal to 0 and v2 equal to 1 meter per second. So you have to define v1 and v2 using this expression. Now next we are trying to define elastic collision in 2 dimensions. So you see in this diagram, an object is at rest, that is your u2 equal to 0, and an object is moving whose mass is m1 with velocity u1 vector, and it strikes, and as a result both the mass m1 and m2 move with different velocity, that is v1 and v2, but with the angle theta 1 theta 2 with x-axis. Now from the, as the collision is elastic, so conservation of momentum, that is your momentum is a vector quantity. So m1 u1, if you consider the component along x-axis, then m1 u1 plus m2 u2 equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2. Now if you consider momentum conservation, or if let me simplify as u2 equal to 0, so you will get m1 u1 equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2. Now if we consider the y component of the momentum, then initially there is no y component movement, so that's why its value is 0 if you consider the y component movement. And if we take the y component movement for m1 v1, that is your sin theta 1, and m2 v2 it's your sin theta 2, but y and y dash they are in opposite direction, that's why m1 0 equal to m1 v1 sin theta 1 equal to or plus with the negative sign m2 v2 sin theta 2. So if we simplify, you will get m1 v1 sin theta 1 minus m2 v2 sin theta 2 equal to 0. And from conservation of energy, as the energy is a scalar quantity, that's why we are not going to take the component. So half m1 u1 square plus m2 half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. So as the velocity is 0, yeah, means the second body of mass m2 before collision at rest. So that's why on simplifying you will get m1 u1 square equal to m1 v1 square plus m2 v2 square. So you can define v1 and v2 using this expression, that is your equation 3 with equation 1 and 2. So this is your collision in 2 dimension. Now let me go for the numerical. It says that two ball bearings of mass m each moving in opposite direction with equal speeds v collide each other. Predict the outcome of this collision assuming that the collision is perfectly elastic. So outcome means the velocity after collision. So m1 equal to m2 equal to m as per the question. Mass is same and moving in opposite direction. So let me consider u1 is your v, another u2 is your minus v. It's in opposite direction. As collision is perfectly elastic, so you can use this expression. You check the expression which we have defined in our previous class, that is your v1 equal to m1 minus m2 by m1 plus m2 u1 plus 2m2 by m1 plus m2 u2. So if you substitute m1 equal to m2, then first term goes off and leaving u2 equal to minus v, because within bracket term also cancel out. It comes out to v1, and v2 equal to 2m1 by m1 plus m2 u1, m2 minus m1 by m1 plus m2 within bracket u2. So check this expression. So m1 equal to m2, so second term goes off and first term within bracket goes off to be 1. So it's your u1 as specified is your v. So you have seen that v1 equal to minus v and v2 equal to v. So what happened? After collision they bounce back. So please check the numericals, and if you have any doubt, any queries, please ask any topic related, maybe from entrance point of view. So this is all about. Thank you.